Well, here's my latest little tinker project here. This is the output of a VFO that I plan on using for a 30-meter transceiver. Many videos ago I showed how to use the nano VNA to build a 30-meter bandpass filter. Well, that's going to be part of this little transceiver project. Anyway, the VFO is a pretty important part, so I tinkered around with that today and kind of based it on what I did for the 40-meter QRP homebrew rig. There's a couple videos on the channel about that if you want to check it out. So I scaled it for 30 meters, which means using a 4 MHz IF, that's going to be about a 6.1 megahertz output. So that's what we're looking at here on the RSP2. And let me unmute it here and turn that down a little bit. But the cool thing about this pretty powerful software, by the way, and let me see if I could zoom in. So I'm looking at the signal from the VFO, and you can see the carrier and a couple of sidebands on each side. As I roll the cursor over the peaks, I get a readout of the exact frequency and the level. So it looks like minus 60.4 dB for the carrier peak. And then for the sidebands, I can read the same thing, where the sidebands actually end up being and what the level is. So it's an easy subtraction to find out how many dB down the sidebands are. So this is pretty powerful stuff for a free set of software and a $125 receiver. So anyway, pretty cool. Let me back off here a little bit. All this is running on a Windows 10 laptop. Control panel up here lets you select different modes and different filters. And you can also look at even and odd harmonics all the way up to a gigahertz with this thing by just changing the frequency or changing the span. We're looking at about I think 2 megahertz. Well, no, not quite. We got it zoomed in, so we're not looking at that that much, from 6110 to 6120 right now. But we can expand it out to several megahertz wide if we want, but then we'd kind of lose the resolution here. So let me pause this and show you the VFO. Here's the VFO. It's not very complicated at all, and it's very stable. So it uses a single N-channel JFET, a J310 right here, and a couple of polystyrene caps, a couple of silver mica caps, a powdered iron low frequency inductor, and a varactor diode over here. So it's tuned by a multi-turn pot here. It's DC tuned. And I've got it hooked up to a 1500 ohm load. And there's the counter with the little source follower buffer amplifier installed, and it all runs off a 9 volt or a 12 volt battery, regulated down to 8 volts by this regulator back here. Okay, and finally here's what it looks like on the pan adapter, the P3, with a very narrow span. Just 2 kilohertz span, plus or minus 1 kilohertz. And it doesn't make much point, but we can listen to it by turning the audio on. So, you know, it's very stable. I've been monitoring this thing for a while now, and it's pretty good shape. So I can move it around here a little bit. The limitation of this is plus or minus 100 kilohertz only. So, but it is very nice to use. Anyway, that's the first building block of this new little project of mine. I'm going to use all homebrew stuff, all junk box components hopefully, and if it works as well as the 40 meter one, I'll be happy. So something to keep me busy during the virus time. Anyway, that's it for now. Keep on tinkering, everybody.